Hello and welcome back to Let's Code Physics. It's been a little while since I've done some recording for Black Hole Battles. I had a number of episodes lined up in a row, so you've gotten to see those. But this is the first time I've recorded in a while. I've done a little bit off camera. As I showed you last time, I've got this sweet background that my brother made for me. But there's also now some better ship graphics. This red arrow is no longer the ship. In fact, we're going to turn that off for right now. I'll show you what that does in just a minute. But right now, what we've got for the ship is this cool hex pattern. Let me get my mover hand. There we go. The graphics theme of the game is using these hexagonal tiles, which is pretty cool. And so this is what the basic player ship looks like. I'm pretty excited about it. I've gone ahead and applied that same sprite to the enemy ship, and just to keep a difference between this ship and the other and the player ship, I've given it this purplish hue to make it look like this alien thing, which is pretty cool, I think. The other thing that I've done is I have found a way to make the background scroll along with the ship. So you might have seen last time when the ship got close to the end of this quad here, the square tile, you would see the blue background. But now what happens when I play it is it's not going to reach that edge. It's going to keep on scrolling. So let's see what happens here. You see how the quad is moving along with the ship. There's my ship in the middle there. And the quad is moving along with it. So if I move it to the left, the quad goes to the left. If I turn this ship to go upward on the screen, the quad goes upward on the screen. But what you notice is that the image itself is changing. The way you accomplish that, and it took me looking up the video and then figuring out something that the video left out to figure out how to do this. So let's say you take, for example, the background. That's the main star and gas field there in the back. What you do is you attach it to a quad. I had that set up before, but what you do is you set it up to where it adjusts the offset of the texture in order to sort of shift the image along with the ship. So I have that set up in this scroll background script. Basically, whenever the ship moves, it adjusts the offset. So what you do is so what I've done is I've actually got two separate scripts. One for the background group that moves the background along with the ship. So this thing is tied to the ship right here. So it's looking for an object named ship. So that would be the player ship right here. I guess I could call it player ship. But all it does is it updates the position to be the position of the ship. So this moves the entire group, this three layers of background, the mid, the background, the back background, and the front background. I guess the front isn't really a background if it's in front of the ship. But what this scroll background does is adjust this offset based on where it's located. So wherever it moves, it adjusts the offset. And here's the trick they left out on the video. So I will put a link in the description below to the video that taught me how to do that. But the thing that they didn't mention, and that I think they thought that I already knew, was on the materials. So you have to create a material out of this thing. Is it the material or is it the renderer? I think it's the... Here we go. It's in the actual, .png. Yeah, it's in the actual, not the material, but the texture. That's what I'm looking for. In the texture, you have to set this wrap mode to repeat. I had it on clamp, and that does something quite different because when you do it on the clamp, revert, yeah. When you put this onto clamp, what it does, it doesn't actually repeat. Unapplied import settings. You know what? I don't want to break this thing, so let's just revert. Anyway, if you don't put it on repeat, you don't get that. You don't get it to go back around to the other side. You just end up, after you go off what would be the edge of the image, you just end up with a black background. So you got to make sure that wrap mode is in repeat. Just a little note there. But yeah, it's great. So now my ship can go anywhere and it will look like it's still part of the game. Of course, I have left the black hole behind. I've only got one black hole for right now for what we're testing today, which we'll get into in a minute. Actually, let's get into that right now, because that brings us to the next aesthetics thing that I want to talk about. So I have started working with the with the enemy ship control. That's what I'd like us to work on today. So if I go to enemy controls, I've got it set up a lot like the player controls. So it includes the same value of the thrust, the same rotation speed. It's again looking for the list of black holes and the list of black hole masses. And it calculates the force on the ship, the gravitational force, using the same equation. But then I've also added in the drag coefficient. So whatever the player ship's drag coefficient is, the enemy ship will have as well. At least that's the way I have it set up for now. Obviously, if the enemy ship is of a different model than the player ship, it'll have a different value. But for right now, I've just got that set up to where we're either both playing with drag or both playing without drag. And then I've added this piece of script, this avoid black hole. We'll get into the details of that in a minute, but basically what that does is it means that this ship, instead of just idling around in a circle like it did before, it's going to try to avoid whichever black hole is selected here. Now I've set it up to be a single black hole so that it just has one black hole to avoid. I'd like to expand that a little bit later to be able to avoid multiple black holes or switch which black hole it's avoiding. But for right now, what it's going to do is swing around the screen trying to avoid the black hole. In fact, if you watch on the scene view here, you can see the purple ship. So my ship, the player ship, is not going to do much right now. But basically, what its tactic right now is to try to keep a certain distance from the black hole. So if it gets too close, it's going to try to go away. So right now it's too close, so it's trying to get away from the black hole. But if it gets too far away, it's going to try to get closer, because obviously I don't want it to, go off to infinity, and it needs to come back in order to be able to interact with the player. So it's basically trying to maintain a certain distance around the black hole. It's obviously overshooting it wildly, but it's basically going back and forth, applying a thrust toward the black hole or applying a thrust away from the black hole. But the reason I wanted to show that to you now, before we get into the code that's creating this motion, I have to show this to you in the scene view because you can't see the enemy ship. Right now on the game screen, it would just be the player ship, not a whole lot going on there. So I created this ship pointer. I used the graphic that I had before. And what I've done is I've set this up as a sprite that sort of goes around the player ship. In fact, let's even pause this so you can see the whole thing. So what I've done is I've created this sprite that goes, in terms of its size, it goes around the player ship. In fact, I'm a little disappointed it's not showing you oh, that's the game screen. There we go. I want the scene view. There we go. Come on now. If I click on, okay, well, it was showing me a border earlier. That's weird. Okay. So basically this thing takes up a certain amount of space around the player ship. And what it does is it applies a rotation based on wherever the enemy ship is. So it's actually a fairly simple script. I had to go through a lot of iterations to try to get this thing. The key was putting in this line to make the angles behave correctly, because this arctangent function returns angles a little bit differently than the rotation expects angles. This one goes between 0 and 360. This one goes between negative 180 and 180. And so they don't agree on how they represent their angles, aside from one being in radians and the other one being in degrees. But it's pretty straightforward. I have it pull in what the player ship and the other ship are. I have it calculate the relative position vector between those two. It normalizes it, although I suppose it doesn't really need to normalize it because that'll get taken care of here, but it may evolve to where I need it normalized later. And so it takes the arctangent of the components to get you the angle that this thing needs to point at, and basically it's gonna apply a rotation here on the z-axis in this line down here. Unity stores rotations as quaternions, but we humans understand them as angles around the x-axis, y-axis, z-axis. So this quaternion dot Euler just turns these three Euler angles into a quaternion. And so what it's doing is it's taking whatever the angle that this relative position vector has, and it's rotating the ship pointer to that orientation. So as I fly around, the red arrow points me toward the ship. No matter which one of us is moving, if he's moving, I'm moving, or both of us are moving, that thing will tell me where the ship is located. So that'll be a pretty useful tool in the game, especially as I try to chase this thing down to get it knocked into the black hole. I did manage, I should have been recording it, but I did manage to knock the guy into the black hole. Almost. I've also set up the enemy ship controls to reset the level whenever the other ship hits the black hole. I missed it. Well, that's just a preview of the type of excitement this game has to offer. I'm still debating about how to manage the camera for this game. The ship pointer is definitely helpful, but it might be nice if the camera... Oops, I died. It might be nice if the camera zoomed out to encompass both you and the enemy ship, but depending on how big the level is, that might get to be pretty big. So leave me your thoughts below about how I should handle that. Should the scene zoom out, or should I just use this thing to help you locate where the enemy ship is? I know I'm going to need to zoom it out some, because right now the ship is taking up a lot of room on the screen. So yeah, so those are the aesthetic things that I've worked on. Not really a whole lot of physics involved in those, so I worked on those off camera. What I really want to work on today is the enemy ship controls. So we've already taken a look at it. Let's take another look. The way this enemy ship is behaving now, if it's more than a certain distance away from the black hole, it's going to shoot toward the black hole. If it's within that distance, it's going to try to shoot away from the black hole. The way I set that up, and let me get my ship safely away from the black hole there. There we go. The way I've set that up in the enemy ship control is in this subroutine avoid black hole. What I've decided to do is to modularize the enemy controls. So there will be a subroutine for avoiding a black hole. There will be a subroutine for orbiting a black hole. There will be a subroutine for chasing down the player. As you fight different enemies, they'll have different ship capabilities, and so that'll require different subroutines. And basically what I'll manage up here in the main control in fix update is for the ship to choose a behavior based on its current circumstances. And I say that vaguely because I haven't figured that out yet. But it should work out great. I'm always so optimistic in the planning phases, aren't I? And here's where I'll cut to half an hour from now when I'm pulling my hair out, wondering about all of the compiler errors I've gotten. Okay, so this we're calling avoid black hole, and basically what it does is it's going to pass the identifier, the IB, the index of which black hole it wants to avoid. So there's a certain number of black holes in the field. Currently there's only one, which means it goes from 0 to 0, because C# starts counting at 0, a behavior I have still not figured out why. And so this causes it to stay away from the black hole. It's not really going to orbit, but you can have this, I can update the change to this, to focus on the closest black hole. So what I'm going to do eventually is when I add in more black holes, this identifier here will be whichever black hole is closest to the ship. Let's see. So what I define here is the distance that that the ship wants to maintain from the black hole. So this is 8 world units. So to give you an idea, the black hole that's being created in here right now is located at 2,2, and the ship starts out at about 0, -2. So where these things, so right now the distance between these two in the game is from -2 to +2 in the y direction. So this distance right here, this vertical distance, is about 4 world units. So if you think about it, that means that the enemy ship is trying to maintain a distance of twice that. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that's the distance from the black hole to about this spot. It's trying to stay, along that circle there. So I get the relative position vector here between the black hole of interest and the enemy ship. Here we find out the ship's current orientation. I guess that should be ship's current orientation, because the current is modifying orientation, not ship. And the reason for that is that the code needs to know what direction the ship is pointing. Is it heading toward the black hole? Is it heading away from the black hole? Is it going around the black hole? Here it determines what direction it's moving around the black hole, clockwise or counterclockwise. The fancy physics term for this is helicity, and so it's just using a little angle transformation here to figure out whether it's moving clockwise or counterclockwise. Even though it's not, going in a circle, like right now, it's moving in pretty much a straight line. Oh, I guess not. I guess it's moving around this way. Well, the point being is that if the enemy ship were to thrust ahead right now, it would be moving this way, and that is a counterclockwise motion around the black hole. If it were pointed this way and going this way, it would be a clockwise motion. And so this positive or negative just tells us, excuse me, the sign of the helicity just tells us whether it's moving clockwise or counterclockwise around. This H value, on the other hand, tells us whether the ship should be thrusting away from the black hole or thrusting toward the black hole. So basically, if it's within that circle, if it's too close to the black hole, then it's going to thrust away. Or if it's greater than the R want, if it's outside that circle, then it's going to thrust toward the black hole. And then the helicity just tells us whether to flip the H value, because depending on how it's oriented, it either needs to thrust this way or the other way. And basically, H is equal to +1 if we're trying to get to rotate counterclockwise, and H is equal to -1 if we're trying to get to rotate clockwise. And then here, the first thing we do is we rotate the ship. So the ship is not doesn't get any special powers just because it's attached to the computer. It doesn't get to instantaneously rotate. It has to rotate at the same speed, or at least a comparable speed to the player ship. So some of the enemy ships will be faster than the player ship or slower than the player ship. So that'll adjust this value, but it doesn't get to immediately snap to the rotation that it needs. It has to go through a finite time rotation, just like the player does. And once it's got its new angle, we figure out what direction the thrust needs to go. Of course, it's only going to thrust in the direction that the ship is pointing, and then it applies the thrust. Now, basically, here's the downside to this design as I have it right now, is that this thrust is going to always either be toward the black hole or away from the black hole. There's no option for a zero thrust, so there's no option for the enemy ship to coast, and there's no option for it to have a negative thrust. There's no option for it to brake. And so that's what's leading to this sort of wild behavior where it's floating around. Oops, and then we get a collision. Maybe I can get this guy inside the black hole. No, okay, too late. But that's what's leading to the wild behavior of the enemy ship, is that it continuously overshoots where it's trying to go, right? So it's trying to be within 8, it's trying to be within about here. Whew, that was a close one, computer. Good job avoiding that. So it's constantly, shooting way past it and then coming closer. On the one hand, this means that the ship doesn't really pose a threat to the player ship, right? Because the player ship can avoid him pretty well. At the same time, it makes life difficult for the player ship, because I've played this a few times. It's difficult to figure out where this guy is and catch up to him, especially since we're applying the same thrust, and especially since he's applying continuous thrust. I mean, he is always running his thrusters, and I'm looking forward to having a thruster animation where you can see that better. He's doing some fancy maneuvering, so he's got the rotating down, but he needs to be able to brake or be able to coast, and I think that'll level him out a little bit. And so what I'd like to do for today's video is add in some options where this enemy ship can have zero thrust or braking a negative thrust. And the way we can do that is in this part right here, because currently all we're doing is checking for whether he's outside of the circle or inside of the circle. We can broaden that to where there's maybe a safe zone in the middle. So instead of it being a circle, there's a nice ring where he's trying to park his ship, as it were. And so I think that's where we can have, for example, the 0 thrust. Excuse me, I had to take a water break. Okay. Let's see. Okay, so we're changing the model to where there's going to be a safe zone, a Goldilocks zone in the middle where the enemy ship is trying to live. And so what we want to do is we want to expand this value here to be a couple of values, one for the inside and one for the outside. And I should also mention this doesn't have to be a fixed value, because when this when we change it up to where there's multiple black holes, which I think I'll probably do in the next episode, when we change it up to multiple black holes, this radius is probably going to need to adjust based on the mass of the black hole. Because that's going to be pulling him in stronger. So he's going to want to maintain a farther distance from a more massive black hole. So let's do this. Let's keep the R want for right now, because I've got it defined below. So if I forget to redefine it, if I get to change the name, it won't blow up at me. But what I'd like to do is, let's say an R. Let's define a range here. Let's define an R min want. So this would be the smallest distance he'd want from the black hole. And let's make that a 5. So let's say this is minimal acceptable distance from black hole. And let's make an R max want. And let's make that let's make that not too much bigger than 8. In fact, why don't we make this one why don't we make this one a 9? Maximum acceptable distance from block hole. Maximal, I guess. No, let's make this one minimum. There we go. And actually, let's go ahead and change this one to a 7 to put it right in between those two. Although I won't be calling on R want, I think, by the end of this. Okay. So here's what I'm thinking, is that the H value is automatically set to 0, right? So when I do this, that's not going to rotate it at all. Okay. Okay, so let's think about this here. Okay. Let's have this thing changed to, if it's less than R min want, then we want to be thrusting away from the black hole. For this one, if we have an R max want, then we want to be thrusting toward the black hole. Now here's the question, what do I do if this, if H is left at 0, then the ship won't be doing any rotating. I don't necessarily want that to happen. So I guess what I need to do, because this was originally taking care of both the rotation and the thrust, I guess what I need to do is define a couple things. Let's define an H for a rotation. And I don't even remember, to be honest with you, I don't even remember why I was calling it H. So let's call this one rotation direction. There we go. And then let's make a new one thrust direction. And let's initialize both of those to 0. Okay, cool. So let's replace these H's with rotation direction. And same thing for thrust direction. Oops, I only need to replace the word rotation, don't I? Here we go. So let's get thrust rotation. And then we'll do the same thing here. Rotation direction. And thrust direction. -1. -1F. I only need that comment once. There we go. Okay, Cool. So here we're just adjusting the rotation direction. Cool. And let's get rid of the H there. There we go. I'm not even sure that comment is valid anymore. Okay, so when I do rotation, here, I need this to be rotation direction. And then here for thrust, what I need to put in is a thrust direction. Yeah, let's multiply you by thrust direction. There we go. And that should take care of that. So thrust can be negative, 0, or positive. I love in class when I use the term non-negative and students say, don't you mean positive? And I say, is there anything left out? And they take like 5 minutes and realize, oh, there's 0. So non-negative means 0 or positive. Little math vocabulary lesson for today. Okay, let's see how well that helps. I've kept everything the same with the rotation direction, so if this breaks, then I know the problem is with the thrust direction. Or it's with this Rmin, R max business. So let's see what our friendly enemy ship does here. I said play scene. Okay. What are you doing, my friend? Okay, so he's getting dragged toward the black hole, it looks like. Okay, I may want to close up that gap. Okay, cool. And now he's trying to get away. And now he's coasting. Okay, because now he feels safe. He's coasting. And now he's turning around, trying to get closer. Oh, no, he's thrusting away. He's going away. Oh, I do not want that to be a negative there. Oops. Okay. Oh, yeah, because the way I had that set up, if he's far enough away from the black hole, he's going to turn toward the black hole and then run away. That's not what we want. Okay. And part of the problem is I have him starting in the safe zone, so I may want to change his starting position. Let's put him right up close to the black hole at the beginning and see what he does. I need to get myself away from the black hole. There we go. Turn it back to scene. I need to move myself to a safe distance from the black hole, I think. Okay. So he is thrusting, so he's coasting away. Now he's moving back toward the black hole. So he's exhibiting a lot of the same behavior that he had before. Now he's left the background. I'm so far away from him. So he's exhibiting a lot of the same behavior as before. He's just being a little bit more conservative with his thrust. Let's see whether he's more likely to run himself into the black hole. I doubt it. Okay. Cool. So he is faring pretty well there. Let's go chase him. Let's go see if we can nudge him toward that black hole. The player ship right now is not moving terribly quickly. I need to up his thrust. Oh no, oh no, oh no! Oh yeah, I definitely need to up his thrust a little bit. Let's see what we can do here. That'll make the game more exciting is when this is moving a little bit faster. But right now, for testing purposes, boom! You are heading into the black hole, sucker. No, you're not. You are avoiding the black hole. Good job. I programmed you well. My first attempt at artificial intelligence, and it's outsmarting me. Okay. Yeah, I think I'm gonna have to program the camera to zoom out because this is not terribly helpful. It also doesn't help that I'm continuously applying thrust, so I could use a little lesson from my own machine here. And yes, I know this is not really artificial intelligence. It's not machine learning or anything like that. I just wanted to have a little moment to gloat. Okay, so that's kind of cool. Let's trim this up a little bit. I don't think we have any more instances of our want. So let's delete that one. I don't think there's a reason to keep that. But let's try tightening this up a little bit. To where he only he's only going to move. He's only going to coast if he's between 6 and 8 world units away, because 8 is kind of far away. Speaking of far away, I'm going to get out of here. Let's move me down a little bit more. There we go. That'll keep me safe. Is it going to keep him in Okay, he's not in view there, so we have to watch him here. Okay, so he is coasting toward the black hole. And let's see, when he gets... It was 6 world units away, so yeah, so there he starts to jet away. Now he's coasting, and then he wants to come back because he wants to be near the black hole. I suppose So here's the question. When should he use a negative thrust? Because it seems like he ought to be able to make use of that. So like right now he might want a negative thrust. Well, there he's just turning. So, okay, so he's deflecting away from it, which is actually probably smarter than my tactic of trying to break. Oh man, close call there. All right, let's go. All right, so this guy's going to come up toward the black hole this way. Let's see if we can cut him off here. Where are you? Where are you? Fire, fire, fire! Oh man. Oh. All right, let's go hunt him down. Yeah, oh, I almost got him in. It's almost like a game of pool. Billiards, for those who use the proper terminology. I'm going to try to remember to add the music to this. Oh, cool, I got him! He fell in! I didn't see it, but he fell in. Yeah, definitely need a death cam set up. I suppose another way I could do it would be in addition to having this thing, I could have like a little screen that shows where he is and what he's doing. Cool. So that's already behaving a little bit better, I think. And I think that works better after he starts, after he gets moving. So actually, oops, wrong button. So actually, let's tighten this up even further. Let's say he wants to maintain a distance of about 5 away. So let's make this between 4 and 6. And let's go ahead and move him. Let's go ahead and move him out a little bit this way. And let's see what happens here on the scene. So he should start moving. Yeah, he starts moving toward the black hole right away. And then he's trying to move away. Cool. Oh yeah, I want to be able to see what direction he's pointing. Here he's about to head toward me. Okay, and then he is... Wow, he's actually doing a pretty decent job avoiding the black hole. I'm kind of impressed with this guy. He's wobbling a little bit. He's wobbling a little bit there because he's trying to get this like perfect approach vector. Oh man, guy, you gotta stop that. You gotta stop living so dangerously. Your code is writing checks that your collider box can't cache. I hope that made sense. I don't know if that made any sense at all. Okay, so I'm pretty happy with that for today. This guy, he seems to be able to avoid the black hole for several passes. He's not yet taking into account me, and so I'll need to adjust that later for him to come after me or avoid me or something. But right now, he can successfully avoid a black hole. What I'm going to do on the next episode is go back to the previous arrangement where there were multiple black holes in the field. I probably won't do it randomized. I'll probably do a simple shape. And what I'm going to do is I'm going to update the code to where the enemy ship identifies which black hole is closest to him and then runs the avoidance code based on that black hole, whichever one is closest. So that'll be what we do on the next episode of Black Hole Battles. Look forward to seeing you then. Have a good day. Bye-bye. I suppose the problem is rotationally symmetric. And so as long as he can avoid one, he can avoid all of them. But he can't always avoid me. Pew, 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 pew. Got him! Ha ha ha!